Let's have a look how we can use the PERT and the 3-point formulas to determine the project duration and the probability related to it. In the previous chapter we described the formulas. Now we will use the results. So we will not do the calculation of those values here. We already have them. Let's have a look at the project. Here we have a project where we have 3 parts: A, D, F, B, D, F, and C, E, F. For every activity you find in the first number the duration and in the second number the standard deviation. Now the first thing to do, and you can do it on your own before continuing, is to calculate the duration of those paths and identify the critical path. Remember that the critical path is the longest path through the network. Let's have a look. Did you do the calculations or not? Let's just see what the results are. First, here I see that we have those 3 paths, and the path ADF has a duration of 5 plus 3 plus 8 is 16. When we do that for all the paths, we see that the path ADF has a duration of 16, BDF has a duration of 21, and CEF has a duration of 19, which means that the critical path is the path BDF. The next thing to do is to calculate the standard deviation of this path. Now be aware, we cannot add standard deviations. We can only add variances. And the variance is the square of the standard deviation. So first we have to determine the variances of the activities B, D, and F. For B this is 4, for D this is 1, and for F this is 2, which means that the total variance is 9, and we get the standard deviation by taking the square root of the variance, which gives us a standard deviation of 3. With those two numbers, with the duration of the critical path and the value of the standard deviation, we can calculate the relationship between duration and probability. We already know that the duration that we find with the PERT values, the 21, has a probability of 50% to be less or more. So we can say 21 periods, well, we have a percentage, we have 50% probability that the duration will be less than 21 periods or 50% more than 21 periods. The reason is very simple. We have in fact a relation here that the distribution, the normal distribution, is a symmetrical distribution. Now we want to know what is, for example, the probability that the project will finish in 24 days or less. And we see the Z value here. The Z value is in fact the number of standard deviations. And the percentages, the surfaces under the normal distribution are always the same. For Z equal 1, it's 34.13%. For Z equal 2, we can find the same, it's around 13%. For Z equal 3, it's about 2%. So when we look at those standard deviations and we calculate, or we have a duration, whatever it is, it doesn't have to be 24, but with that duration we can calculate the corresponding Z value, and we know that that there is a specific probability that we can finish the project in that duration or less. Now you see also, which is very interesting here, if your boss tells you, no, I want you to finish this project in 15 days or less, you'll see that there is only a 2.28% probability that this will happen. Adding these elements to your evaluations, to your project knowledge, will help you to prove to the people if their demands are realistic or not. Let's have a look at the different curves. Here I put all the curves for all the paths. Normally we only do it for the critical path, for the red line. And we see that depending on the duration, I can identify what is the probability. We see that the blue line is far to the left, the green line also, we only have the red line, and typically, which is a little bit a disadvantage for this method, is that typically we only look at the critical path. Now what can happen? We have here a path CEF which is close to the critical path, but it's not equal to the critical path. But now we see that the standard deviation of the path CEF is larger than the standard deviation of the critical path, which means that that curve is flatter. And we see when we are looking at the relationship between duration and probability using the red curve, we also see that from a period around 23 periods, this is not the case anymore. And we don't see that typically using the PERT method. That's a disadvantage of the PERT method. When we understand what is happening here and we have the standard deviations of the different paths, we can of course take it into account and find the right answers. But you have to be careful here because typically, like I said, the people only look at the critical path. But paths that are close by, you have to consider them too, certainly when the standard deviation is a lot higher. That's about the application of the PERT and the 3-point estimates using the probability curve. In the next presentation, we will be looking at another technique, which is called the Monte Carlo analysis. I'm looking forward to seeing you there. Thank you and bye-bye.